Hello students, today we are going to discuss in this lecture requirements and design. Basically requirement means what? It's basically what the system should do, and design is how the system should do. Okay, that means how it does this. Whatever has been found in the requirement, that is what the system should do, the design should specifically underline how it should be done. Okay. But in practice, basically, this line, the way it is thought of, theoretically it is thought, that line may not be possible to draw. That is, in practice, both the things actually overlap with one another. The system architecture may be designed to actually analyze the requirements, okay, structure of the requirements, or even some systems may even interact with the other system to generate the requirements. Okay. Uh, some use of some specific architecture may also be used to satisfy the non-functional requirements. Okay, so this type of things can be there. That is where they may be there may not be a very clear-cut guideline, or clear-cut separation between the requirements and design. So there are some common guidelines for writing the requirements. So normally what is done when you write when you identify the requirements and you want to write in a natural language, so it is always better to have a standard format to write all the requirements. That means all those requirements should be put in a standard format. Okay, that should be used. Same format should be used for all the requirements. Okay, that means to write the requirements. So uh, and that use of the language should be always consistent, and that means suppose for writing the mandatory requirement, always you should use the you should use the cell, and if it is desirable requirement, not mandatory but desirable, then you can use the should. So this standard and consistent way should be used to write the requirements. Okay, similarly the text highlighters should be used to identify some key parts of the requirements. So computer jargons should not be used. It is basically better to avoid computer jargons. Okay, and uh, include some explanation to some part of the requirement wherever it is necessary. There may be some common problems that may arise while using the natural language to write the requirements, like lack of clarity. While trying to make the requirements more precise, there may be we may that the sentence structure may becomes more difficult to read. Okay, document may become more difficult to read. Similarly, the requirements confusion, that is sometime while writing the natural language, we may actually mix up the functional and non-functional requirements, which should not be there actually. So it leads to confusion. So such requirement confusion should not be there. While writing natural language, there is a tendency to create this type of confusion. Similarly, requirements amalgamation, that is several different requirements may be expressed together because you are using a natural language to write the requirements. So the problem may be that you while specifying the requirements, you have mixed up uh, different requirements. That means you have actually expressed the number of requirements together. Actually, that should have been different requirements, but you have clubbed it. So this type of problem may arise while using the natural language. Here are some of the you can see the requirements which are written in natural language from the insulin pump software system that we have discussed in our case studies. So, blood sugar level to be measured by the system um, every 10 minutes. Some that is if required every 10 minutes, and insulin should be delivered accordingly. So that can be written in the natural language this way. Basically, if the blood sugar level is it's not necessary actually uh, to measure the blood sugar level very frequently, or if it is not very frequent and very less number of measurements are done, then blood sugar level may actually go up. So both this should be somewhere in between, that is the proper estimation of the time should be done to provide the insulin to the patient. So that particular period has to be specifically specified in the requirement. So similarly, self-test routines may be required in a specific duration. So this kind of requirements can be, you know, can be specified in natural language as shown here. There is another kind of, another way of specifying the requirements, which is called as the structured specification. In a structured specification approach, basically requirements are standard are actually uh, are written in a very standard way, and so there is very less independence from the part of the requirement writer. uh, for him or for the requirement writer, the option for choosing different ways of writing requirements is very limited. That is, the the person doesn't have much freedom to write the requirements according to his or her will. So basically they have to always specify in a standard way or standard format. Okay, so many software systems actually, which are mostly the embedded control systems, uses this kind of standard format for specifying the requirements. Whereas this kind of format is not very suitable for business applications, because in business application the person needs some freedom to specify the requirements according to his or her will. So this kind of depending on the software kind of software to be developed, if it is a embedded control system or something like that, then standard ways may be used. While specifying the functions or entity, the requirements, that is the function or entity like requirements, in that case the form-based specification may be used. That is where you we can describe the inputs, and that means where the from the inputs come from, or where the output goes to, because if we specify the functions, uh, then we can have those specification of the inputs, the description of the inputs, where they come from to the that is to the function, and where the function outputs are going. Okay, so uh, similarly, description of the actions to be taken. Okay, and information about the information needed for the computation and other entities used, and also for the functions, pre and post conditions of the functions can be stated uh, in the formal specification, and side effect of the functions. So in such cases, when we use such functions and entities as part of the requirement, form-based specification becomes a suitable one. Another way of specifying the requirement is the tabular specification. Uh, it is basically tabular specification can be used as supplement for the natural language specification. So, in certain scenarios where you need to specify the number of alternative courses of action, then the tabular specification is more usable. You can say instead of natural language, the tabular specification looks more usable. Now, suppose in case of the insulin pump system, if different level of computation of insulin is required to be shown, then tabular specification will be a more suitable one. So such kind of things where you need to have the alternative courses of action specified, then tabular specification is most suitable form of specification. So here is an example of the tabular specification for the insulin pump. That is, level of dose of the insulin being calculated depending on the whether the sugar level is falling, stable, or increasing. Okay, rate of increase, etc. So this is how the tabular specification can be done or can be written.